Number 7 says the theory of plate tectonics developed from a synthesis of other theories. Synthesis means like a putting together. So they took several theories and put them together into one big theory called plate tectonics. All right, so let's look at our answer choices. Okay, so they gave you a plate map, which is nice, but I'm thinking you can probably answer the question even if you don't have the plate map. It says, which combination of the following theories was most directly responsible for the development of the theory of plate tectonics? Okay. First of all, Pangea is not a theory. Pangea is a thing. It was like the big landmass when all of the continents were joined. Special relativity does not have anything to do with plate tectonics. That's like Einstein stuff. And he did not do plate tectonics. He was like physics. Okay, heliocentric solar system. Nice. That means the sun is the center of the solar system. That doesn't have anything to do with plate tectonics. Continental drift does. Darwin's theory of natural selection. Again, that's life science. It's like, why do certain animals survive better than others? And germ theory. Well, that's definitely not plate tectonics either. The only one that has two that are even decent is A. Continental drift, which was proposed by Alfred Wegener. And seafloor spreading, which was Harry Hess, although you really don't need to know the names of the scientists. But he figured out, hey, continents were once joined and drifted apart, but he couldn't really tell you why, which is why it wasn't accepted at his time. And then Harry Hess figured out a key component to the fact that, hey, there are all of these little broken little lines right here through the middle of the ocean, and that's where new crust is formed as the plates spread apart. Okay, so that's what seafloor spreading is. So we're going to go with A. 8. In an area known as the Ring of Fire, volcanic island chains have formed in the Pacific Ocean. What most likely caused this to happen? Okay, this is the Ring of Fire. It's also a song by Johnny Cash, but that's not what we're talking about. The Ring of Fire is right in through here, okay, around the edge of the Pacific Ocean. Kind of includes this. Okay, the Pacific Ocean is a big plate that's actually being pushed underneath, is actually converging with most of the other plates around it. So there's a convergent boundary here, there's a convergent boundary here, there's a convergent boundary here, and a convergent boundary here, convergent boundary along the north part of North America. There's some kind of divergent and transform boundaries through here. But convergent boundaries here, convergent boundaries between the Nazca and the South American plate, all of that's convergent boundaries. In an area known as the Ring of Fire, volcanic island chains have formed in the Pacific Ocean. We also know from our studies that volcanic island chains go with convergent boundaries. When oceanic crust subducts underneath other pieces of oceanic crust because they are pushing together. Okay, so we're going to go with convergent boundaries. Okay, volcanic islands, basically if you get volcanoes, it's because of a convergent boundary, unless it's an exception like a Hawaiian hotspot. Okay, here we go. Number 9. The diagram below models the movement of two tectonic plates. Oh, look, it's kind of like what we just talked about. There's a big arrow right here, although you can't maybe notice it. There's another arrow. These two plates are coming together. This is oceanic crust. This is continental crust. What is occurring as a result? Well, there's a trench occurring. There's a volcanic set of mountains occurring. And this plate is being pushed underneath, and that is called subduction. So let's see what our answer choices say. Mid-ocean ridge. Nope. That's where plates diverge. Subduction is occurring because oceanic crust is denser than continental crust. That is true. Okay. A divergent boundary is forming. No. A transform boundary is forming. No. So the only one that makes any sense is B. All right. Number 10, a model of the water cycle is shown which two processes can allow pollution from fertilizers and other agricultural practices to enter the groundwater or surface water. All right, so let's go to our model. Okay, transpiration would be like water evaporating from the leaves of trees and stuff like that. So that's pretty much going to be just water molecules. Evaporation, pretty much just water molecules evaporating up from the ocean or the river or whatever. Condensation is is water vapor going to liquid. So going from a gas to forming clouds or whatever. Precipitation is stuff falling from the ground. Okay. But here is where we get all of the fertilizer is down here, right? On the ground. So it's when all of this precipitation gets to the ground that it either runs off, so that's one of them, or it percolates into the groundwater, percolates into the rock underneath the ground. So we're going to go with runoff and percolation. And again, percolation just means that it's filtering down into the rocks and soil. Number 11, a student draws models of Earth and the sun in different positions, which drawings should be used to represent summer in the southern hemisphere. Okay. So southern hemisphere would be this one. But look at this particular model. Neither hemisphere is tipped towards or away from the sun. So this is going to be either fall or spring, because this is the model shows an equinox. Okay. This one, even though the Earth is dimmed out for some reason, it's the northern hemisphere that's tipped towards. So the northern hemisphere is having summer, and the southern hemisphere is having winter because the southern hemisphere is tipped away from the sun. All right, let's look at the other ones. Here, northern hemisphere is experiencing summer because, again, it's tilted towards the sun. Southern hemisphere is experiencing winter because it's tipped away. Here, the southern hemisphere is experiencing summer. Why? Because of the way the Earth is tilted. It's the southern hemisphere. It's tipped more directly into the sunlight. And northern hemisphere is having winter. Okay, so I've been labeling so long that I forgot what the question was. Which drawing should be used to represent summer in the southern hemisphere? Okay. The only one that had summer in the southern hemisphere was D. All right, number 12. Refer to the diagram above. A neap tide occurs blank while a spring tide occurs blank. Okay, you need to remember neap tides equal 90. Neap and 90, as in 90 degrees. As in a right angle, things are like this. So the sun and the earth and the moon are at 90 degrees. There's a 90 degrees, so that would be Z. And here's another 90 degree. Boom, boom. And oops, I scribbled over it, and that's X. So a neap tide would occur at X and Z. Spring tide, think straight line, okay? The sun, moon, and earth are all lined up straight for a spring tide. So that's going to be W and Y, because all of those are in a straight line with the sun. Okay, so W and Y. So let's just pick. A neap tide occurs at X and Z. So that's good. X and nope. 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 Okay, so that's going to be the only one. So it's A. All right, one more question. All right, the beginning of autumn in North America is in September. but the beginning of autumn in South America is in March. The diagram shows the positions of the Earth, the Moon, and the Sun on one day in September and on one day in March. Why does autumn start in different months of the year in the northern and the southern hemisphere? Notice, please, that no matter where we are in our orbit around the sun, the tilt of the axis is always off in the same direction. So, and we always move counterclockwise, okay? On these diagrams, go counterclockwise, because that's what the planets and stuff appear to do if you were to like hover above the solar system and take a look. So here is September, which means this would be December. And because the Earth is tilted in the same direction, okay, here's the equator. That would be the southern hemisphere over here having more direct sunlight and the northern hemisphere having less direct sunlight. Okay, and then this would be our northern hemisphere spring equinox. And over here, again, this is pretty sloppy, but there's the axis of rotation. Here's the equator. And now we're having summer because this is June, and the northern hemisphere is tipped into the sun. So why does autumn start in different months of the year in the northern and southern hemisphere? Well, it's because that in, for instance, December, it just has to do with the tilt of the Earth on the axis. So in September, the northern hemisphere is finishing up summer and starting fall. But the southern hemisphere, as we go this way, is going to be more and more directly into the sun. And so they're going from spring into summer. So Earth's orbit, that doesn't have anything to do with it. Remember, distance does not determine seasons. North America has a larger landmass. Seasons. Nope. I mean, that's true, but that has nothing to do with seasons. Moon has a greater pull on South America. No. Moon has nothing to do with seasons. The reason we have seasons at all is because the Earth is tilted. Because the Earth is tilted 23.5 degrees on its axis, okay? So when we're having winter, southern hemisphere down here is having summer. And when we're having summer, southern hemisphere is over here having winter. And it's because the Earth is tilted on its axis. All right, that should do it.